Okay, so I'm going to walk through lab assignment number 4 because overall you guys did really well, but I think there are some things that would help you to see my thought process as I work through the problems. So for scenario 1, it says data from cross-sectional studies suggest that exercise may protect against depression, but it's unclear whether exercise leads to less depression or less depressed people exercise more. So there's an issue of temporality here. A researcher recruits a group of 400 women who are not currently clinically depressed. So this should clue you in. We are recruiting a disease-free cohort. She surveys the women as to their weekly exercise patterns, so she's assessing exposure status, and identifies 100 of them as non-exercisers, 200 of them as moderate exercisers, and 100 of them as heavy exercisers. I'm going to change my color. After 2 years, the researcher assesses depressive symptoms among the women. Okay, so we have an outcome that she's measuring. 20 of the women in the non-exercise group are diagnosed with clinical depression, 38 in the moderate exercise group, and 7 in the heavy exercise group are diagnosed with depression. So question 1, this is an example of what kind of design. So this is a prospective cohort study. As I said, we recruited a disease-free cohort, we assessed their exposure status, and we watch them over time for their outcomes. So the exposure, as we said, is exercise, and the outcome is depression. So we're going to draw the 2 by 2 table, or in this case 3 by 2, because we have 3 levels of exposure for this study. Okay, so we always put our disease outcome on the top. So in this case it's depressed and then not depressed. And then we're going to put our different levels of exposure status. And it doesn't matter if you do heavy, moderate, none, or non-moderate, heavy, just as long as you keep track of which group is which. So I'm going to do heavy, moderate, and none. And then we can start to fill in our table, right? So we know that we had overall 100 women who were non-exercisers, we had 200 who were moderate, and we had 100 who were heavy. And then among each of those groups of women, we had 20 in the non-exercise group ended up with depression. We had 38 in the moderate exercise group end up with depression. And we had 7 in the heavy exercise group. And then, of course, we can just subtract to get our numbers who did not have depression. All right, and there's our 3 by 2 table. So then it's asking us to calculate the cumulative incidence per 1,000 people for each of these exposure groups. So here we're going to calculate 3 different numbers: our heavy exposure, our moderate exposure, and our non-exercise exposure. So in heavy, so let's remember, cumulative incidence is number of cases over population at risk. So among our heavy, we ended up with 7 cases of depression among our 100 women who were in our heavy exercise group, our population at risk for that level of exercise. So this is 0.07, which is also 70 per 1,000 women. In the moderate exercise group, 38 over 200, which equals 0.19, or 190 over 1 per 1,000 women. And in the no exercise group, 20 over 100, 0.20, which equals 200 per 1,000 women. All right, so there's our 3 calculations of cumulative incidence. Okay, so then, then we go on to the next question. So calculate how many cases of depression are attributable to non-exercise using heavy exercisers as your comparison group. So here's a clue. So we're asking, first of all, we use the word attributable, and we're asking about how many cases. So if you remember back, when we calculated attributable risk, or otherwise known as risk difference, we were calculating the number of cases attributable to our exposure. This is different than a relative risk, where we're calculating essentially the ratio, or the dividing the increase in risk instead of the number of cases that are at risk. I'll show you guys. So basically, how many cases is asking for a number of cases, not a proportion. Most of you got this one. So we ended up in our non-exercise group, we had 20 per 100 women, or if you remember, actually 200 per 1,000 women. And then we want to subtract that from the number of cases in our heavy exercise group, which was 70 per 1,000 women. So we ended up with 130 excess cases of depression per 1,000 women attributable to non-exercise. So again, another way to say this is that non-exercise accounted for 130 excess cases per 1,000 women of depression. Okay, and then it's asking, calculate the relative risks and specifically cumulative incidence ratios, because from these data we can calculate cumulative incidence of depression among each of the exerciser groups compared to the non-exerciser group. So here we're going to end up with two measures of relative risk, right? We've got our heavy versus non, and then our moderate versus non. And for heavy, go back, our heavy exercisers, the cumulative incidence of depression was 0.07. In our non-exercisers, the cumulative incidence of depression was 0.20. And this ends up equaling a relative risk of 0.35. For our moderate versus non, the cumulative incidence of depression among our moderate exercisers was 0.19, and these are just from on the previous page. And then our cumulative incidence of depression among our non-exercisers again was 0.20, so this equals a relative risk of 0.95. And I'm just going to put, so relative risk, right, in this case specifically cumulative incidence ratio, is our cumulative incidence in the exposed divided by our cumulative incidence in the unexposed. That's what we just calculated. Okay, so we end up with two relative risks, 0.35 and 0.95. And if we were to describe these in full sentences, so we're saying in this case with 0.35 that heavy exercise, first of all, is protective because we have a relative risk less than 1. And specifically, if you remember, to calculate the how much protective factor it had, we could subtract this from 1 and times 100, and we'd end up with 65%. So among women who were heavy exercisers, they had a 65% reduced risk of depression compared to women who are non-exercisers. That's why we would say that. Here, if we subtract from 1 and multiply by 100, we'd end up with 5%. So women who were moderate exercisers had a 5% reduced risk of depression compared to women who were non-exercisers. So what's our conclusion regarding exercise and whether it's protective against depression? So in this case, I would say that yes, it appears exercise is protective against depression. Specifically, women who were heavy exercisers got the most protective benefits. As remember again, the heavy exercisers had a reduced risk of depression of about 65%. Moderate exercise tended to give a little protection, but really not very much. Again, the reduced risk of depression among moderate exercisers compared to non-exercisers was only about a 5% reduction. So it really seems like the most benefit comes from heavy exercise, where the women reduced the risk of depression by 65%. So some combination of those ideas would get you a right answer on that one. Okay. So on to scenario 2. So scenario 2 is saying the scientific literature indicates that moderate and severe mental retardation may be in part explained by environmental toxins. You suspect that lead poisoning, the prevalence of which is as high as 10%, so there's our exposure, 10% of the population may be exposed. So the prevalence of which is as high as 10% among children ages 1 to 5 in Philadelphia, and you suspect it may be the cause of moderate to severe mental retardation. And moderate to severe mental retardation is prevalent in 0.3% of the population. So the first question for this scenario is, would you use a cohort design or a case control design to study this relationship? And this should be a huge red flag or ringing bell when you start to see the prevalence of a disease outcome as incredibly rare as 0.3%. And what that means is that you want to use a case control design. Remember, for a case control design, we select people who have our outcome and who don't have our outcome, and we compare their exposure histories. It's perfect for rare diseases because you can seek out the people who have the disease. If we were to do a cohort study with this and hoping for outcomes of retardation, we would have to have an incredibly large cohort to end up with enough cases of retardation to be able to say anything about their exposure patterns. So always remember, if you have a rare disease, so about less than 10% in your population, you want to select a case control design so you can ensure you are finding people who do and do not have your disease outcome of interest. So then the second question, what measure of association between your exposure and your outcome could you calculate? So always remember, from case control studies, we calculate odds ratios. We cannot calculate incidence measures from case control studies. We must calculate odds ratios. And then the last question, so draw a 2x2 table that you would use to organize the data from this. So always for our case control studies, we have those who are diseased, in this case have mental retardation, and then non-diseased. So those would be the ones who don't have the mental retardation. And then our exposure status, let me just make sure to get the language right. So lead poisoning, so you may look at, you could either say this is lead poisoning or not. Oops. Let's see if that works. Lead poisoning or no lead. You could look at sort of levels of lead in their blood. You could look at lead in their home, something like that. But either way, we're going to have our diseased and non-diseased in our columns and our exposure, lead or no lead, in our rows. Okay. Scenario 3. An investigator wanted to determine whether vitamin deficiency was associated with birth defects. By reviewing the birth certificates during a single year in a U.S. county, the researcher located 205 infants born with neural tube defects, a type of birth defect. These children were cases in the study. So here we go, we're talking about cases. A total of 1,000 healthy births were selected at random from the certificates to form the control group. So here we go, cases and controls. And in this case, it's because neural tube defects are extremely rare outcomes. So we'd need to do a case control study to look at the exposures associated with that outcome. All mothers were given a dietary questionnaire that measured their intake over the past year and so included their pregnancy if you included the past year. And this, you can kind of get from this that this dietary questionnaire also asked about use of supplementary vitamins. So among the mothers who gave birth to an infant with a neural tube defect, 84 reported no use of vitamins, and 237 of the control mothers reported no use of vitamins. Okay. So what are the exposures and outcomes in this study? So oh gosh, I'm hitting something there, huh? Okay, let me erase. So exposures. Now this was you can do this either way. You can either say the exposure was use of the vitamins or non-use of the vitamins. I actually find it a little easier to say that the exposure was non-use. Because then, as you can sort of get from this problem, we're going to end up with what is the sort of that non-use is the risk factor. We think that's the risk factor. And then our outcome, obviously, is neural tube defects. So draw the 2 by 2 for this study. So again, we always have our disease and non-disease along our columns. So we'll put neural tube defects and not neural tube defects. And then we'll have our exposures along the side. And as I said earlier, gosh, I was just trying to wipe something off the screen that you guys can't see. Okay, so our exposures, in this case, I'm going to choose to use no vitamins as my exposed group and yes vitamins as my unexposed group. But again, you can flip it the other way. The key thing here is that you remember what you counted as exposed and unexposed, because that's going to matter in your interpretation of your measure of association. All right. Oh, I have to fill in my numbers. Sorry about that. So we had 205 babies with neural tube defects as our cases. We had 1,000 controls. If we looked at the babies with neural tube defects, 84 of the moms said that they did not use vitamins. This leaves 121 of babies with neural tube defects where the moms reported they did use vitamins. We can do the same here. 237 of the control moms did not use a vitamin, and 763 reported did use a vitamin. So that's our 2 by 2 table. So then calculate the measure of association that could be produced from these data. So again, case control studies, we always calculate an odds ratio. We cannot calculate a measure of relative risk because we don't have incidence. And if you remember, our formula for odds ratios are AD over BC. So let's go back, and if I can mark this, here are our cells. And it's the cross product, remember? Oops, that's a messy arrow. Cross products. Let me undo that because that's going to be too messy to read my numbers. Okay, so A is 84, D is 763, B is 237, C is 121. Doing this calculation, we end up with 64,092 over 28,667. I think it's, yes, 667. And then we end up with an odds ratio of 2.23. So our findings in a full sentence are that among women who did not take these vitamin supplements during pregnancy, their odds of having a baby with neural tube defect were increased 2.23 times. Or another way to say this, they had a 123% higher odds of having a baby with neural tube defects compared to women who did not take a vitamin or did take a vitamin supplement. Okay, so the key pieces here, we always, if we calculate an odds ratio, we always talk about odds. So higher odds, increased odds, lower odds, however you want to say it. Be very careful to avoid the word likelihood, because if you remember, likelihood refers to incidence and measures of relative risk, and especially for cases or situations where our disease outcome is very prevalent in our population, our odds ratio will be very different than our measure of relative risk. In this case, it's a very rare outcome, so it doesn't matter as much, but just when we're calculating odds ratios, it's always best to stick to odds. So again, among women who did not take vitamin supplements, they had 123% higher odds of having a baby with a neural tube defect compared to women who did take a vitamin supplement. That would be the way to say that in a full sentence. And then, what is one concern you have about the quality of information collected from the mothers in this study? So there's certainly a lot of concerns that we have about measuring diet. Retrospectively, people are terrible about reporting their diets. What I was trying to get at in this question was recall bias, right? So that should always come to your mind. You have a case control study. You have asked the cases and the controls to report on their exposure history. recall bias is always a concern when you don't have an objective measure of exposure. Because remember, those moms who have babies with neural tube defects, it's a traumatizing and scary thing. And they're probably thinking back, oh gosh, what did I do during my pregnancy that might have brought this on? Oh, I didn't take my vitamins, something like that, right? So those women, or maybe they're nervous and they're ashamed to admit they didn't take their vitamins because they know they ended up with an unhealthy baby. So whatever way it is, the bottom line is, in case control studies, there's always a concern about recall bias, because the people who are the cases are going to report or recall. There's always the risk they're going to report or recall their exposure history differently. All right, so hopefully this was helpful to all of you. You guys overall did a really good job, and I just thought it'd be helpful to see some of these calculations kind of in motion. So thanks a lot.